Hi everyone, welcome to the study of O.D.E. We are considering nonlinear, and in today's focus we are considering the method of change of variable. So to solve this, second derivative of y plus first derivative of y minus 2y is equal to x. First of all, we consider the reduced form, which is the reduced form of this, which is the homogeneous part. This is equal to 0. So to solve this, we are going to let our y to be equal to exponential mx, so that now we obtain our y prime. We differentiate this once to get m exponential mx. We differentiate it again to get y double prime, which is equal to m squared exponential mx. Then we substitute our value of y double prime there to obtain m squared plus m minus 2 exponential mx. I have factored exponential mx outside, which is equal to 0. And we note that exponential mx can never be equal to 0, meaning that our m squared plus m minus 2 is the one which is equal to 0. So this is a quadratic equation which can be factored into this form. Factorizing this quadratic equation, we shall get we shall have m plus 2 into bracket m minus 1, which is equal to 0. This is the same as that part here when you factorize this quadratic equation. From this quadratic equation, your m1 is equal to negative 2, and your m2 is equal to 1. Then our complementary form becomes, so our yc is equal to c1 exponential negative 2x plus c2 exponential x. On how to obtain the solution of homogeneous equation whereby you have root distinct, check in my YouTube channel. Now, by method of variation of perimeter, which we are applying, we are going to let our u1 to be equal to u, that is our c1, which is equal to u, which is equal to u1 of x. Then we shall let our c2 to be equal to u2x, which is equal to u, which is equal to u2. Then meaning that now we shall have u1 y1 plus u2 y2. This is prime, which is equal to 0. And we shall have u1 prime y1 prime plus u2 prime y2 prime, which is equal to rx. In our case, our rx is equal to x. So now we are going to have, we shall have our u1, our y1 is exponential negative 2x plus our u2 prime exponential x. This is equal to 0. Differentiating this, we are going to get negative 2 u1 prime exponential negative 2 plus u2 prime exponential x is equal to x. Now from algebra, we can write this in this form. This equation can be written as exponential negative 2x negative 2 exponential negative 2x exponential x exponential x u1 prime u2 prime. This is equal to 0x. So it is the same because this is a linear system of equation. It can be written that way. It is the same thing. Now from here now we are going to get what is called Wronskian. Wronskian, it is when you get the determinant of this part here. So we get the product of the main diagonal and we subtract the product of the other diagonal, which is equal to, when you multiply this, the power will reduce by 1, so you will have exponential negative x there is minus and minus here. So you have minus this, which will be now plus 2 exponential negative x, which gives you 3 exponential negative x. So that is our Wronskian. Now to obtain our u1 prime is given by 1 over Wronskian. Then we multiply by 0x exponential x, which is equal to, we are dividing by this, so we shall have exponential x over 3 bracket, this is 0 minus x exponential x, which is equal to negative x exponential 2x over 3. So our u1 prime is equal to negative x exponential 2x divided by 3. So to get our u, this is u prime, we integrate in both signs. So that's why I've written it here. This can be integrated by part. So integrating this part here by part, your result will be x over 2 exponential 2x minus exponential 2x over 4. Then you multiply everything by negative. So this is multiplying by negative, whereby we can write as negative x over 6, multiplying this one here. This is x. Then negative and negative will become positive. You have 4 times 3, which will give you 12 exponential 2x. We can factor negative. Negative 1 over 12 outside, so that now here we shall have 2x, so that when we remove the bracket, we will have negative x over 6, and here we will have negative 1. And we also factor exponential 2x outside to obtain that one. So our u1 is negative exponential 2x over 12 into bracket 2x minus 1. Now to get u2 prime, it is Wronskian, multiplying by the determinant of exponential negative 2x, multiply negative 2 exponential negative 2x 0x, as shown there, over other exponential negative x. This is the Wronskian, which you obtain above. Here we are going to get x exponential negative 2x. This can be taken up so that now it reduces the index by 1. So you have exponential negative x multiplying by, you take it out up 1 so that it become positive. So the result will be this one here. Now this is the u prime. So to get u, you integrate in both signs. This is integrated by part, whereby we let our u to be x, we differentiate u so that you get your u prime as 1. Then our v prime to be exponential negative x. When you integrate this one, you integrate this part here on both sides, it will give you v, and when you integrate this, it will give you negative exponential x. Meaning that now in the other x exponential negative x, when we integrate it, will be other negative x exponential x minus negative exponential x. When you integrate this part here, it will give you, this part will be plus, then after integrating, the result will be, when you integrate negative exponential x, negative and negative will give you plus. When you integrate negative exponential x, it will give you negative. So that is why we have this part here. Factoring negative for the outside and exponential negative x, we get this x plus 1. Now, our u particular is given by u1 y prime plus u2, u1 y1 plus u2 y2. Our y1 is exponential negative x, our y2 is exponential x. So substituting, we shall have negative exponential negative 2x over 12 into bracket 2x minus 1, 2x minus 1 minus that into bracket x plus 1, we close the bracket. After multiplying now, what has happened is that this exponential 2x has cancelled with this to become exponential power 0. Any number power 0 is 1. So that is why now here we have negative 1 over 12 in bracket 2x minus 1 minus that this x and this one, exponential x and exponential power negative x, will cancel out, so that now we'll be left with this part here, negative that x plus 1. So we can simplify this. When you simplify this, the result using the LCM, the result is negative 1 over 4 in bracket 2x minus 1. Now our general solution will be given by our y is equal to y complementary plus yp. Our y complementary was c1 exponential negative 2x, c2 exponential x minus 1 over 4 bracket 2x minus 1. So that is our result which we obtain. And remember our ODE was y double prime plus y minus 2y is equal to x. So that is the solution of our given ODE. Thanks so much for taking your time to study with me. For more such studies, kindly tune to my YouTube channel so that we may continue learning together.